kids, Mrs. Geiger. I'm going to show you what the conventions are for naming compounds. So you're going to want to get out your notebook and follow along as we do some practice problems. So you're going to write naming compounds. Now the convention that I'm going to teach you for naming compounds is called the IUPAC system. Now, IUPAC stands for the International Union of Pure and Applied Chemists. The Regents exam will often say, use the IUPAC system. I'll let you know, I'm only going to teach you this one convention. International Union of Pure and Applied Chemists is a group of scientists that basically make up rules about what we should do in terms of chemistry. When new things are discovered or when we make breakthroughs, they're the ones that get to decide what the conventions are. And that allows all chemists throughout the whole world to basically speak the same language. All right, so let's talk about the IUPAC system. We're going to start with ionic bonding. So when you have something that's ionically bonded and it is made out of two elements, we call that binary. All right, and all of the ionic compounds on the Regents exam that are ionic are going to be binary. They're only going to contain two elements. They're going to have a metal and a nonmetal. And what you should know is that the metal always comes first and the nonmetal always goes last. And it's the same order that the elements appear on the periodic table. So, elements that appear on the left side will be first. Elements that appear on the right side of the periodic table come last when you're writing a chemical formula. So here's the convention. The metal is going to keep its name. So if that metal is magnesium, we're just going to say magnesium. If that metal is iron, just going to say iron. Nickel is nickel. Nothing changes about the name of the metal. The nonmetal, though, gets a special ending. We're going to take off the ending of whatever the name of the nonmetal is and change that ending to IDE. So we're going to do a few examples now. So our first example is MgBr2. I'm going to go across, by the way. So I'll do, let me just erase these stray marks. I'm going to do the first one, MgBr2. So Mg is the symbol for magnesium. And Br is the symbol for bromine. But we're going to change bromine to bromide. All right, so the ending here changes from ein to ide. All right, let's do our next one, LiO. Ooh, there's a typo here. This should say Li2O. And I know that because oxygen has 6 valence electrons. And lithium only has 1 valence electron. So you're going to need 2 lithiums with 1 valence electron each. Sorry, that's kind of scooched in there. In order to balance out the charge and make lithium oxide, which we know would be Li+. I can put a 2 out front here, and we'd end up with an oxide ion with a charge of 2-. So I know I'm going to need 2 lithiums for every 1 oxygen here. And you'll notice that magnesium bromide is the same concept. Magnesium has 2 valence electrons, so it's going to lose those 2 valence electrons and become a 2+ ion. And then each bromide has 7 valence electrons. So it's going to gain 1 electron from each of those bromides. Or each of those bromides is going to gain 1 electron from magnesium. So that's how I know that magnesium bromide is going to be MgBr2, while let's name this one on the right side here, Li2O, is called lithium. And oxygen becomes oxide. Right, we take off the ending oxygen and we change it to oxide. All right, so go ahead and copy down the other 4 examples, and then you're going to pause the video and practice. So our first example is SRO. Our next example says ALI3. The next example is NAF. And then we have ZNS. All right, so go ahead and pause the video, and I'm going to show you the answers when we come back. All right, wonderful. So we're back. So SRO, we read as strontium oxide. ALI3 is aluminum iodide. And that's a funny word because iodine becomes iodide. NAF is sodium fluoride. And ZNS is zinc sulfide. All right, let's move on to our next type of example. All right, so if a compound contains a polyatomic ion, all right, so good thing you have those polyatomic ions memorized, so you'll be able to really quickly name these polyatomic ions. Now, the convention here, I don't have the convention for if you have ammonium. Ammonium is the only positive polyatomic ion. And in that case, you would just use that word, ammonium. You just name it. All of the other polyatomic ions, almost all of them are negatively charged, which means that they're going to bond to a metal. So I have the convention here for when you have a metal and a polyatomic ion. So the metal, same thing, keeps its name. And guess what? The polyatomic ion also gets to keep its name. And that's because the polyatomic ion is already named based on being an ion. So you memorize those names so that it's easy for you to recall them now. All right, so let's do 2 examples, and then you're going to do some examples on your own. All right, so my advice for you is that you put parentheses around the part of the compound that has the polyatomic ion. You'll notice that these are not binary. They have more than 2 elements. Some of them have 3 elements, and some of them have 4 elements. So that's how you know it has polyatomic ion, has many elements, more than 2. All right, so in this first example here, we have MgSO4. So which piece of this is the polyatomic ion? Is it MgS or SO4? You got it, it's SO4. So my advice is to put parentheses around the SO4, and that'll help you figure out what the 2 pieces are that are bonded together here. This is called magnesium sulfate. All right, sulfate is SO4 2 minus. Magnesium ions would have Mg plus 2. Perfect. All right, so let's do this next one, NaSCN. Which elements here make up the polyatomic ion? You got it, you got it. It's SCN. All right, wonderful. So Na is the symbol for sodium. Oopsie, why isn't this working? Sodium. And SCN is called thiocyanate. You might notice that Cn by itself is another polyatomic ion, and Cn is cyanide. So SCN is thiocyanate. They're related to each other. Thio actually means sulfur. All right, so go ahead and copy down the other polyatomic ions, LiOH, compounds containing polyatomic ions, I should say. LiOH, NH4OH. Ooh, this one is special. It contains 2 different polyatomic ions. That's a little tricky. CaCO3, Li2SO3, and AlOH3. You'll notice here that when you have to multiply a polyatomic ion, we use parentheses. Similar to in math class, you learn parentheses can mean multiplication, and we put the subscript on the outside of that polyatomic ion. All right, so go ahead and pause the video and practice and see if you can get these. All right, kids, so let's check your answers. LiOH is lithium hydroxide. NH4OH is ammonium hydroxide. And that's because our two polyatomic ions are NH4 and OH. CaCO3 is calcium carbonate. Calcium carbonate makes up chalk and also shells. CO3 is calcium carbonate. Li2SO3 is, oh, I have a typo here. This should be sulfite. My bad. Lithium sulfite. And AlOH3 is aluminum hydroxide. So go ahead and check your answers.